Hi everybody, thank you for coming. My name is Mathias Verraes. I'm an independent consultant. I don't really do Drupal, but I help companies and organizations to build enterprise applications, usually in PHP. I help with domain modeling, with cleaning up legacy code, these kinds of things. And today we're going to talk about, and I brought a lot on the link you see over there. We're going to talk about objects. I know that you guys have been moving with Drupal 8 more into an object-oriented system, adapting or adopting components from Symfony as well. So I think this is a really good move. I think this is going to improve Drupal a lot in the long term. And this is going to take some time, but you know, baby steps. So there's something I want to really fix in your mind. Systems are about behavior. We tend to look at the software we build from a very data-centric point of view. And sometimes it is just that. Sometimes it's just a database at the center and your application is nothing more than putting stuff in and putting stuff out. But that's a very technical way of looking at systems. That's not how our users see it. For the users, a system is about behavior. It's about things that it does, ways that it reacts to inputs, etc. This is how they talk to us. This is how they say, well, when this happens, then I want this to happen, and when this happens, that should never happen because of this, etc. So we should actually try to envision our system that we build from the point of view of this behavior. State, actual data, is more like a side effect. We store the state in databases in order to guarantee this behavior. If I do this, then you know when I come back 2 days later, I still want to see this, but maybe somebody else has done that. We need to persist stuff, but that state is just like a detail. It's important for us. We worry about it all the time, but for the end users, it's just it's not that important. And when I say systems, I like to use the sort of definition that people use in general systems thinking, which has nothing to do with software, but the ideas are very relevant. And that is that the system is always composed of systems, and a system is always part of a system as well. So everything is systems. When I'm talking about an object, that's a really small system. When I'm talking about a function, when I'm talking about an application, or when you're in fact talking about your whole organization and your customers and your suppliers and your employees, that's also a system. And all of this can be defined in sort of behavior. So let's talk about objects, but before we do, let's talk about functions. This is sort of a generic way to write a function. It takes two inputs, x and y, it returns some value, z. But what does this function do? So there's something very interesting that is called a pure function. Pure function is something where what you see here is the only thing determining the output of the function. So when a function has no side effects, and when this function is not influenced by something on the outside, then we call this a pure function. In fact, in functional programming, this is like the core idea. You try to build everything with pure functions. Whenever you have a function that actually does something outside of the scope of this function, like write to some global variable, or write to a database, which is also a bunch of global variables, if you think about it, or sends an email, or all of these things are side effects. When this function is influenced by something that is in a database or in a global variable, in a session, in something else, this is also not a pure function. This is just, I mean, we could talk about functions all day, of course, but this is something that I think is quite important to understand. So, what does this function do? Well, it could be anything really. There's no way of knowing. It could be that the input is a string, and the y input is some array or some nested array with values, and the outcome we don't know. There's a way to actually enforce what happens. So here, when we want to test this function, in theory, we'd have to test this against every possible input and define an output for every possible combination of inputs. That's of course impossible. This is why in some languages we have something called type safety or typing. So here what you, if we could somehow say that this function only takes integers as its two arguments, and it only returns a 1, a 0, or a -1, then the range of this function, the possible outcomes of this function, is now very limited. So this is telling us something about this code. Is there anybody who can now sort of guess what this function would do if these are the types? So if you have two ints for the inputs. Yeah, a comparison, exactly. So here we can, it's sort of a maybe naive implementation, but if this is just taking two integers, then it will compare them and return 1, 0, or -1, depending on how they compare. So if we could, in fact, use this, if we had, so in some languages you can actually define this very explicitly. In PHP, we cannot do this, but in Hack language, which is, if you've heard of it, it's the language that Facebook is building on top of PHP. So Facebook is not replacing all their PHP, but they are adding a new layer underneath it called HHVM, and a new superset, there's a new language on top of it called Hack. And this is what you would do in Hack. You can have some types in Hack that help you limit the possibilities of this function. You cannot, I don't think you can say you can limit it to -1, 0, and 1, but you have some degree of certainty here. So typing, depending on the language, it's like a continuum of things you can actually do. Why is this so interesting? Well, types are a way of describing your code. It's like a logical proposition. If you have a function that you can type in a certain way, then you're saying to your system there's nothing else that you can do with this. So this gives you some evidence of some proof of what this function, how it's going to behave. So this makes it easy for programs to actually reason about your code. They can understand what is happening. This is very interesting. If this sounds like some abstract artificial intelligence kind of thing, PHP does this in fact. PHP will throw fatal errors when you try to put a value in a function and this function is actually type hinting against a different type of value, then PHP is going to crash on that. So this is a way of guaranteeing the correctness of your code. If you use an IDE like PHP Store, for example, or Eclipse, they also reason about your code. They will give you like code completion hints, etc., based on your types. So that's a very powerful tool. This improves or increases the correctness of our code. And that's very useful, as we will see later. So we have some tools for that. We can use classes, we can use interfaces, and we have types. We cannot do everything. We don't in PHP. We don't have very granular types where you can say, I want an integer from this range or this starting point to that endpoint. We cannot type in on scalars at all in PHP. For primitives, I think we can only, we can type in on arrays, on closures, callables, that's sort of the primitives. But we can define classes and we can type in on those. So we have some tools. We cannot have return types in PHP. There's a proposal now to add it in the next version of PHP, so hopefully we will have it. So types prevent bugs that are related to having the wrong kind of types. So here, for example, this is a very classical bug. This is one that I'm betting everybody has encountered at least a couple of times in their lives, and they're very hard to find out because, have you seen it? What the problem is? We are swapping article ID and subscriber ID. If you have type hinting for that, there's no way to make mistakes. There's still other ways you can introduce bugs, but at least this category of bugs is now prevented. If this looks like over-design to you, having an object for nothing else than an ID, then I think you never have this problem. I do this in fact, and if you look at languages like C# or Java, this is very common. For some reason in PHP, I have never seen anybody else do it. I have no idea why. I think we have this sort of wrong idea in PHP that objects are expensive and classes should only be used to make some really big important things in your system and not for this kind of very small things. But it is in fact very cheap to do. So let's move on now. We still haven't really talked about objects. So this is a pattern that you have a lot in code. If you work with functions, so you have a function that takes some data, d, as an input, and then some arguments, a and b, and then returns some data, d, quote. And d and d quote are the same type, the same kind of data structure. So this pattern happens all the time. So here's like a PHP version of it. If you do an operation on some data with some arguments, then it returns some new version of this data. And then we have another operation where I do the same kind of thing. So what we want to achieve actually, and this is the core idea of object-oriented programming, is to encapsulate this data that we have. And why? Because this will make our system easier to reason about for ourselves. We're not doing most of the things that we do as a programmer or that we do to make better programs. They are not to help the compiler, they're actually to help ourselves or to help our colleagues or to future people working on this code, which could be ourselves. Most of the code I write in 6 months, I don't remember why I did something, but if I can read this in the code, if this code is expressive, then this helps me a lot. So let's look at a very simple example. It's sort of a made-up example. But let's say you have some article and you represent this with a simple associative array. This is something that a lot of PHP does, and I think in Drupal this is very common to represent data this way. But now there's a problem with this. If we want to modify this article and say that this is now published, so this line might be anywhere else in the code, maybe this is used in many, many places. But if you don't have encapsulation, when I want to change this, and I say, actually having a string for that is really silly, I don't want yes and no, I want true and false. So now I change it here, publish false, but now of course all my old code that still uses yes and no will need to be changed manually. So whenever I want to change something in this data structure, it sort of propagates to the whole, I see that I have a bug there, this should have been true of course. But so this data structure is completely open. You can touch it anywhere. You can just any code that wants to can manipulate this array, and this makes our code very hard to reason about and very hard to change because now it's everywhere. So that's not what arrays are meant to be. This is what arrays are. An array should be a list, a collection of values that have the same type. So this is not okay. All of these fields have different types. This should be, in some languages, this could be a record. In PHP, we can do this with an object, but this is not a good way to use an array. These are good ways to use an array. So I have a list of integers of the same, they are all the same type. Here I have a list of objects of the same type. Here I have the same thing with some index. This is like an optimization. I can actually, if I want to find, if this is like a huge list of articles, if I want to find this article and I know this ID, this will be very fast. So that's the only reason we would do something like this, to index this array to make lookups faster. But we could just as well loop over the whole array and look at every element and then filter the one that we actually want by ID. So it's an optimization. And these keys could be strings. I'm not telling you not to use string IDs, string keys if your IDs are string. Or if you want to make a map of something, that's a good reason to use an array in PHP. If you use hack, then there's some more data structures that you can use, like vectors and maps and sets, etc. Is it making sense so far? So the reason to turn this article into an article object is because now we can encapsulate all this behavior. And behavior, something like publish an article, That's behavior. We can see this very much from a data-centric point of view. If you see publishing an article from a data-centric point of view, then we're saying publishing an article means changing one value to another value, changing the published value from false to true, and then persisting this, this new version of this article. So this is like an update, so it's a very CRUD way of thinking. If we look at it from the point of behavior, those are just details that we want to hide, that we want to abstract away in the internals of our objects. So publishing an article can mean, it means a lot of things. It means that this article now becomes visible on the front end, etc. And maybe there's maybe it goes to mailing and all these kind of things. So this is how you think about objects and systems. It's behavior first. The data, the state is a detail. And I just added this slide after talking to somebody here about this little vulnerability that you had. So maybe you recognize this code. This is where the what did you guys call it? The Drupalcamp or something? This is the line where it happened. This array values wasn't there, so it was possible to actually inject different values into this I variable, and then they would be used to actually build the query and with all the consequences that you have. So having objects for these kind of things and making these objects encapsulate everything, and then not having to deal with arrays, with strings and arrays at this kind of point, makes a lot of problems go away, in fact, or at least makes them very contained and very local, which is the point of encapsulation. So what we're doing here, this is to go back to where I started a moment ago, is instead of having a function that operates on data and then with some arguments, we hide the data in this object in the second line, and then we call operations on this object. So, and then here's an example, of course, article publish. So this is sort of an idea that I think many people do wrong. They move to objects, but then they have setters and getters for every possible value inside this object. When you have setters and getters for everything, it doesn't matter that your internal variables are private, because you're making them public anyway with all these setters and getters. So there's a very subtle difference between set published true or false and say article published. Article set published is a very data-centric way. It requires you to understand how the internals of article work and how you publish an article. When you have a method called article publish, you're saying, I want this article to be published. I don't care how it does it internally. So I don't care if it's yes or no in the string field there, or if it's Boolean, true or false, or if it's some other thing, or maybe 3 or 4 variables need to change. So this encapsulation is the core idea of object orientation. There's a lot of things that I won't have time to talk about, but if you get this is already going to help you a lot. Look at how things behave, encapsulate this behavior, encapsulate these operations, and hide away how the data actually looks like on the inside. So how we're going to do that? We're actually going to design our objects from the outside. This is why we do things like test-driven development. The idea in test-driven development is that you use an object the way that the client code would use it. So you write this object from the point of view of this client code, and then afterwards, when you have written this test, then you actually implement the internals of this object. So this is a very, this sounds weird if you're used to thinking, okay, I need to have an article, and an article is a title and this and that. That's this data-centric habit. But if you start with, I need to have an article, and my customer says this article needs to be able to be published, and they say something, I have a very simple example here, that they have this business rule that says, well, when an article has been published, we cannot change the title anymore. We don't want to enforce these kind of rules on the outside of our article. This is what encapsulation, again, what it means. When these kind of business rules need to be enforced, they are enforced on the inside. So we define the behavior of this object by looking at it from the outside, and we say, okay, we need an article. An article always has a title and a body and an author, for example. And then when somebody publishes the article, and then after that they try to rename it, it should throw an exception. So this is what this is PHP unit basically. This is a feature in PHP unit where you can say, I expect that the next method is going to throw an exception. If this method does not throw an exception, then my test fails. So this test is guaranteeing that when I first call this, then call this, it will actually throw an exception. So you see, we have designed this object. We have designed the methods, the interface, the behavior of this object from the outside without worrying about how it looks like on the inside. It's a very, very powerful way. And actually, when you develop this way, when you write tests first and then implement them, you end up with better code, and you also get into this mode where you do your thinking up front, and then the implementation is just typing, because you type some code, you run the tests, oh, it's still red, oh yeah, I forgot something, you fix the error, and now it's green, so now you have some evidence at least that your code is correct. So here's another way of looking at it. Objects should be consistent at all times. So an object is responsible for its own consistency. And this is sort of a contract. This is an agreement between the client code and the object. Where the client code, for example, has a type hit saying, I want an article. This should be a guarantee to the client code that if you say that you are an article, then you are a valid article. I don't have to look inside you and check whether you are valid. That's not my responsibility, that's your responsibility. That's our contract, that's our agreement, our protocol. This makes our systems very simple, because you can just pass around objects and you can trust them. You can trust that they are okay. So in this case, if we do it like this, so I had in the previous example, I had all my arguments in the constructor. If we do it in this way, then we're saying that this article might be, here it's not a consistent article, because the business rule says an article has a title and a body and an author. Here we have like 3 steps where this article is not consistent before it eventually becomes consistent. That means that if you somehow leave out one of these lines and then pass this article to some other code to use it, they will now have to worry about, is this article in fact valid or not? Right? So this introduces a lot of defensive coding where you have to check things all the time, and then if this is null and if this is empty and if this is unset, etc., etc. This makes it a lot more elegant. So and here I have some more code that shows how this article is in fact guaranteeing its own consistency. So now I'm back at having an article where the required fields are put in the constructor. This article itself, this constructor, is going to throw an exception whenever somebody's trying to put in there that is not correct. So it's not trying to clean it up. In some cases you might try to clean something up, but if you don't have a title and you need a title, there's nothing you can do. So this sort of pushes, so a lot of my code has in this sort of pattern where the constructor takes a couple of arguments. Not all of them. You don't necessarily need all of them, only the ones that will make this article valid and consistent. And then for each of them, I only have one now, of course, you throw exceptions whenever there's something that you don't like about it. So this forces anybody who tries to make an article object to make sure that everything that goes in is correct. And all these objects that work together, they will actually, if they all do this sort of thing, they push all these problems to the earliest point possible. This is something called fail early. So the sooner we fail with something, the less bugs propagate throughout the system. If something fails at the very beginning, then the rest of your system is not going to do things like put it in a database and then maybe after 6 months you discover that half your database is corrupt, etc. So it's a very good pattern. You guarantee consistency everywhere, and it's only at the edges that you have to deal with things like user input, etc. Still making sense? If you have any questions, just shout or raise your hand. So I sort of mentioned this already, objects are contracts, and here's an example. If I have something that sends story updates to subscribers, for example, this object does not have to worry about is this article fit to be sent. Because it's type hinted here, because this is a contract, and this is a contract, I have guarantees that these are completely valid articles and subscribers, so I can safely send the article to the subscriber without having to worry about all these internal details. Objects, and this is, I mentioned this earlier, systems compose and systems are composed of parts. For every object you make, you can start digging deeper and finding ways to make objects for the smaller parts as well. So I already mentioned that I have objects for IDs. In fact, I have objects for everything. I use primitives only at the deepest level. So let's see here we have a title, which is a very simple thing. You can represent this title with a string, but if I represent it with a string, I have to worry about the correctness of the string. I have to worry about the behavior of the string on the outside. There's probably not going to be a lot of behavior on a title, but there might be. Same with the body, same with the author. In fact, if this author, for example, is like a Twitter handle, I think I have an example about it. So objects, we compose them of smaller objects. And again, this, instead of having to check if these strings are correct here, we don't have to worry about them because they have already been guaranteed by these contracts. And you can use this for more interesting values than just strings. Here I'm using a time slot, which is, we are now in the time slot from 15 until 1550. We could represent this with an object called time slot, which is composed of two objects called time and, well, both time, and one is called start time and one is end time. There is, in fact, behavior here. So these two objects, of course, guarantee that they are valid times. 2561 would not be a valid time. 2359 would be, of course. This time slot object can in fact also guarantee that end time is later than start time. So now if I have something that uses time slot, it doesn't have to worry about any of that. It can actually start asking questions, like is this moment in time, is it part of the time slot or is it not part of the time slot? This could be a method of this time slot object. So this pattern is actually called a value object, and here is the Twitter handle example. So a value object is an object that represents a value, nothing more. So it doesn't, it's like the smallest object that you can have. A friend of mine actually said value objects are the heart and soul of object-oriented programming. I love that quote. This is true. You can actually have all these very little small things that interact with each other and that you can pass around, and they're very lightweight. So here, this Twitter handle object is guaranteeing. Well, first of all, it's guaranteeing that it always has a name. It's not. You cannot have an empty Twitter handle object here. So again, this makes it easier for other systems. It guarantees the formatting of this string, and then if I want to use it, if I need it as a string again because I want to represented in my user interface, for example, I can just convert it back. And so, many people will think that you risk having too many objects that way. They're actually very, very cheap in PHP. You can have lots and lots of objects, and it's not going to affect your performance. Of course, if you do a lot of calculations and database calls, etc., inside those objects, okay, it's going to be slow, but that's not the object's fault. It's your code. So you can trust me on that. There's actually, well, you don't have to trust me. In fact, there's actually an article somewhere. I should have added the link where somebody is measuring the time difference between using arrays for everything and using objects. And in the latest versions of PHP, the objects win. So there you go. I have another example. I'm stressing this point of the value objects because they are so powerful and so easy and so elegant. Money is a great example because money is not, you cannot represent money with a number. If you say, oh, you still owe me 5, then I'm like, what, 5 bananas? These two things belong together, the value and the currency. So it makes a lot of sense to represent money as these two things combined. So this is again, a little bit maybe naive implementation of money. But here's some of the methods that this money object could have. These value objects attract behavior. If you start thinking about all these values, they do have behavior. Money has behavior. When I want to add €5 and $5, I cannot add those. That is behavior. This is something that our clients might say, hey, wait a minute, when you do this, I want this to happen. When you try to add euros and dollars, I want the system to give me some error message. I don't want it to ignore this problem. So that is behavior, and this behavior should not be in some hidden away in some 5,000 line method somewhere. It should be encapsulated close together with this money object. Another one that I think is very interesting is allocate. Allocate means if I have I don't know, €5 and I want to give you 60% of my company and you 30% and you 10%, how can I actually divide this money? Because money cannot be divided all the way. So this allocate method would actually create 3 new money objects with, if there's 1 cent that I have to distribute to one or the other, this kind of thing. All this behavior can be inside this allocate method. And you would have a lot more. There's a library that I wrote on GitHub that you can find with the whole, this as an elaborate example. Values are immutable. Like the number 5, if I add 1 to it, it becomes the number 6. It's not 5 with a new value, it becomes something else. So when we use value objects in our code, we're actually going to enforce this immutability, and this is why. Let's say Jim and Hannah both they share the same object, which is €2,500. Now if I give a coupon to Jim for €500, it should actually decrease Jim's price, but not Hannah's price. And here this code proves that they're still equal. So I've given the coupon to Jim, but Hannah has it as well, because this is how objects work in PHP. They are by reference. So because here we assign them to the same object. And you can say that this code is wrong and I shouldn't have done that, but here it's very obvious because I'm here doing a very explicit assignment. But in real code you are passing objects around everywhere, and then you cannot keep track of where you are actually where you have used them. So what we'll do is in fact make this subtract method, or any method basically, instead of changing the actual object itself, it will return a new object. And we can see that here. So this is, I had subtract here, and here it's add, but it's the same thing, of course. So we have, of course, this validation first. I cannot add money of a different currency. So if I have euros, I cannot add dollars. if this guard passes, and we don't throw an exception, then here we can see we are actually returning a new money. So the original one of 2,500 euros is still 2,500 euros, and now I have a new one of 2,000 euros that I will assign to Jim in the example. Making sense, this sort of immutability stuff? This is sort of, how should I put it, a little bit unnatural in PHP. People are not used to working with immutable objects, but it's very powerful. It's, again, one of these very simple things that massively simplifies your system, because you don't have to worry about it on the outside. Please.
Would it then will make more sense to implement this add method as a static method where you put two money objects inside?
So the question is if this would have been better done as a static method. You could do that, it would work, but then you're sort of back in functional programming. And there's going to be lots of places where it's more natural in object-oriented programming to do it this way, and to actually have these methods on the other. But it takes some getting used to. If you see code like this, if you expect this to actually change its value, then this is sort of weird, but you get used to that really quickly. But so there's nothing wrong with using static methods for something like this. But I think it cleans up the code a lot if you do it like this, and it becomes very. My example is sort of contrived. In real systems, these value objects attract so much behavior that it becomes very natural to just move them around, and then you don't modify them, but you move around new versions. But I understand your hesitation, of course. So these are immutable objects. There are, of course, things that change over time. We had the example of an article. Articles change over time. Can be simple things. The title changes. Maybe somebody fixes some typos. Somebody publishes it. The example that we had. So when something changes over time, we cannot identify them by their value. They have an identity which is sort of separate from their values on their own. But this is a natural thing. If you change your name, if you change your address, if you change your email address, you're still the same person. You will still identify as the same person. This is why we use identifiers in our code everywhere. This allows us to talk about something without actually having it. So we can now refer to this article by its ID. We know that it might change over time, but we know it's still the same one because it still has the same ID. So, and of course you can see now, I shortened it a little bit here, but this entity is actually composed of value objects. So you would have body and author in there as well. So what we see is value objects are like the smallest thing. Value objects only depend on primitives and on other value objects. Remember, time slot depends on time, and time depends on strings. So entities, they have life cycle, they change over time, they have stable identity, and they are composed of value objects. So we don't, entities don't know, entity is sort of a very overloaded term. There's a lot of things called entity. I'm using the naming from domain-driven design, where an entity is something that it only depends on other entities or on value objects. So you can see how we are sort of moving up a level in the sort of layers of complexity. We have primitives, we have functions, then we have value objects, now we have entities. And the next step, of course, is having collections of these things. So we might have, of course, more than one article. Something is responsible for keeping track of those. So we call this a repository. What is a repository? It pretends to be like a collection, an in-memory collection of articles. In reality, so this is just the interface here. In reality, in the implementation, of course, it will need to talk to some persistence, like a database or disk or something else. So what we see, of course, repositories depend on entities because they are collections of them. They also depend on value objects to identify objects, etc. So these are just some basic. There's a lot more of these kind of patterns. We still have 10 minutes. I'm going to go a little bit faster now into some code example. How you can move from typical procedural code to abstractions into objects. So this is sort of something that should make sense to you guys. In reality, this kind of code can be very long. This is typical of procedural code. It becomes very long. In object-oriented code, if you do it well, you never have more than a couple of, I don't know, 5 or sometimes 10, or often just one line in each method. This sort of shows how we're decomposing, of course. So what are we doing? We're selecting some orders, or we're counting some orders in the database, and then if this client or this customer has more than 5 orders, we send them a mail using the gold template because they're a gold customer. If not, then we do another query to find how much money they have spent. And if they have spent more than 5,000 something, we don't know here, we send them the silver template, etc., and then the bronze template. Of course, the obvious thing here is to start changing, instead of having this customer, here you can see this customer array, that should be an object, and of course the money here should be money instead of just values. So we would have something like total amount spent is larger than new money, 5,000 euros, for example. So the comparison of these two money objects is also a behavior that we hide inside the money object. If we start talking to the business and really trying to understand what that code is doing, a business rule can also be an object. In fact, everything can be an object. In object-oriented programming, as I said, you shouldn't use primitives and you don't use big blocks of procedural code. You make objects for that. This object, we call this pattern a specification. This specifies when a customer is actually has 5 orders or more. So it's taking the database and the constructor because it needs this database object as a collaborator. And then the only method we have is satisfied by. So this specification is satisfied by this customer object whenever this customer object has 5 orders or more. So we can have a lot of these very small specification objects. We can actually start passing them around as well. So instead of having a big block of code, we can now start extracting business rules, and the business rules can be our objects. You can move them, you can do fun stuff with it. We can start combining them into something we could call a strategy. A strategy describes the concept that we had we had a nested if block, remember? Let me just show you. So here we had like nested ifs, which is an anti-pattern because that makes code hard to reason and to change and to understand. Here we actually got rid of this and we just defined our strategy as a set of specifications. So we're saying that the mailing template strategy, or I could have called it a mailing template picker or something, will actually pick your template based on the first specification that you pass, right? So so this is like I didn't write the code because I'm too lazy, but this is like a fallback thing. If you pass this specification, and so we will call the isSatisfied method on this specification. If you pass it, you get this template, etc. So it's just like a fallback system, but we're separating the work of going through this process. We're separating it from defining the process. So now our strategy is an object as well. This is very interesting because objects can be replaced. We can have polymorphism. Polymorphism means that you as a client, all you want is a mailing template strategy, but you don't care which one. You don't care how it works. So maybe, for example, we have two installations of this system, and one installation is for somebody who likes to send bronze email or gold emails to people who buy 5 products. Your other customer might want an installation where the rules are different. So now we can actually have different strategies, different set of rules for different installations if we want to. This can be configured. So depending on, so instead of, if we go back to the procedural bit here, If in this case, if we have this code and we have to add a new installation, and the client is saying, yeah, but I want some things different. I still want gold templates, but only if this and this and this condition are true. Then you would have to add more and more if statements here. It would become a big mess. If you have this kind of polymorphic strategies here, you just add another tenancy strategy. And then all you have to do is make sure that you pick the right one. So it all becomes very composable. The client code that calls this method doesn't have to know which one it is. It only knows that it guarantees this contract. So now the whole procedural code that we have starts looking like this. You're giving up control. You're actually, instead of having all these procedures, you just compose an object. This is like in your configuration where you say that the promotion campaign uses the tenant A strategy. And then when you actually execute this, you're saying, you know, I have this campaign, send a newsletter to customers that have registered before date. So this is our customer repository, for example. It has a method registered before, and this will actually give us customers that have registered before this date. I think it's very obvious. This is code to me that tells a story. This procedural code that we have, this one, this looks like code. I love programming, but I hate looking at code. We spend too much time reading code and not enough time. So if our code looks like this, if it looks like the business, we don't have to parse all of this procedural code. Parsing code is a very slow process. This is our brains are not computers, so we write not for the computer but for ourselves. So this is why I want to conclude and say that, you know, great programming is great storytelling. Thank you for listening. Are there any questions? We have a couple of minutes. I know this was like a very superficial introduction, but please.
You mentioned a little bit about the patterns. For me, for example, it's really hard sometimes to choose the proper pattern. And sometimes there are a lot of approaches and a lot of patterns. And can you give me a suggestion how to choose a proper pattern and how to try implement them more, and how to understand when the code is a little bit sticky and I should implement some
Yeah. So your question is basically how to discover and how to decide on what kind of things you need.
Actually, I read a lot of books about it, and I still think I'm too far from implementing it on the practice.
Yeah. Well, it's kind of a general question and hard to give a general answer, of course.
But I want to hear your opinion about
Yeah. Well, part of it is just getting used to it, and if you want some heuristics, start with value objects. Try to model everything as value objects, and then when you feel it doesn't work, you can upgrade them to something else. That's, you know, it's a very blunt instrument, the way I put it now, but try it like that. That helps. Second is to assume that everything is going to be an object. So one technique that you can try is something called CRC cards. You just take index cards and you write down responsibilities. And if you have two responsibilities on the same card, then you probably need to split this up. And then you find names for each of these cards, and you put them on the wall and see how they relate and how they behave. And then it becomes, well, this is one technique that helps to discover these things. So doing, you know, drawing stuff and experimenting and that's sort of how you learn these things. But I'd love to come to me afterwards so we can talk some more, maybe specific problems that you have. Any other questions? Nobody? Okay. Thank you for listening. Have fun. The slides will be on my website, or they are on my website already, and I have some links on there as well, so just go there if you want to see them.